Okay, let's dive right in. We've got a fascinating source document today, basically an architectural verdict.
Mm-hmm.
It's digging into a comparison that's on a lot of minds.
Mm,
Databricks versus Microsoft Fabric.
that's right. And our mission really for this deep dive is to get past the buzzwords,
Yeah.
understand the core technical differences, the architectural ones, based on this source, and see how these powerful platforms stack up.
And the central question the document tackles is pretty simply, is it Databricks or Fabric?
Right.
But as we look through the material, it kind of became clear the answer might be a bit more nuanced than just either.
Indeed. Yeah, the verdict really leans towards them being complementary,
Complementary.
not direct competitors across the board.
Which is honestly a really key insight for anyone trying to figure this stuff out.
Absolutely.
So whether you're, deep in the trenches with one platform, maybe thinking about the other, or just curious about where data platforms are heading,
Mm-hmm.
this deep dive is definitely for you. Let's maybe start right at the bottom, the foundations.
Right, the architectural base. Storage and compute. Good place to start.
Okay, storage first. Our source talks about Databricks building on Delta Lake.
Yeah.
That's their open source layer, brings AC transactions, handles streaming and batch,
Right, and it usually sits on top of your existing cloud storage.
like ADLS, S3, GCS, managing that underlying bit.
You are. Fabric, on the other hand, introduces One Lake.
One lake, okay.
It's pitched as this unified storage layer, and importantly, it also uses the Delta format underneath.
Okay, same
And
format.
core format. And it has these native shortcuts for referencing external data without moving it.
Right.
The architectural difference, the source points out here, Databricks gives you that direct granular control over the lakehouse storage itself, while Fabric abstracts it more, aims for simpler workspace-based governance over what looks like a single store.
So it feels like Databricks is saying, here's the powerful open foundation, you tweak the knobs, and Fabric's saying, here's a unified view, we'll handle some of the plumbing.
That's a great way to put it. Yeah, a really different philosophy right from the start.
So what about the compute, the brains of the operation?
Databricks leans heavily on Apache Spark, well known for performance,
Mm,
and they augment that with things like Photon.
the C++ engine.
Right, and SQL warehouses for BI workloads, model serving for ML. It gives architects and engineers, a lot of fine-grained control. Configuration, optimization, it's all there.
And Fabric's compute approach, is it similar?
It abstracts the Spark engine more. It also has a SQL warehouse component, and it leverages the Power BI DAX engine, the engine behind Power BI itself.
Okay.
The source highlights that Fabric simplifies things with a shared compute model, so the takeaway is kind of clear.
Control versus simplicity again.
Exactly. Databricks prioritizes that granular control for tuning. Fabric aims for simplified, mostly auto-scaling execution.
Okay, this theme is definitely emerging right away. Granular control in Databricks, simplified abstraction in Fabric. Let's shift to the data itself, how they handle different types, different scales.
Makes sense. Starting with file formats.
Yeah.
Both handle the basics, CSV, JSON, Parquet, Delta. That's table stakes.
Right.
But the source does note Databricks supports a wider range out of the box. Things like ORC, Avro.
The data serialization formats.
Yeah, binary files, XML, even Excel directly. Fabric seems more focused on formats that play nicely within its One Lake world.
So if you got a real mix of legacy stuff or specific streaming formats, Databricks might have broader native support there.
That seems to be the implication, yeah. And that kind of flows into data ingestion, too.
How so?
Well, Databricks is really built for both batch and native streaming. It has features like autoloader.
Right, simplifies getting data from cloud storage.
Exactly, and direct integrations with things like Kafka, event hubs, plus a whole ecosystem of connectors.
Okay, and Fabric's ingestion story.
It leans more towards batch, primarily using its data pipelines, think copy data activities, or Power Query for transformations during ingest.
Power query, okay.
Familiar to many, very familiar. And it uses those One Lake shortcuts for accessing external data, plus really tight integration with the Microsoft suite, SharePoint, Dynamics 365, Dataverse.
Right, the M365 connection.
Big time. So the architectural difference, Databricks is positioned for those complex, high-volume, maybe real-time ingestion jobs. Fabric offers a simpler, often low-code way in, especially strong if you're already living in that Microsoft world.
Got it. And what about just sheer volume? Petabytes versus terabytes.
Yeah, scale matters. Databricks is explicitly designed for petabyte scale, both batch and streaming.
Wow.
It really excels there, with Delta Lake, Autoloader, DLT, Delta Live tables.
DLT, right. Simplifying pipelines.
And the Photon engine helps chew through that data.
So where does Fabric fit in volume-wise, according to the source?
It's noted as being, let's say, better suited for terabyte-scale business data, especially for semantic models feeding BI.
Okay. Performs well with small to medium data sets. But the source adds a little caution. Data over a terabyte, especially if it's going into Power BI models, needs careful handling.
Right, import mode limitations, potentially.
Potentially, yeah.
Yeah.
So the architectural point. Databricks for massive scale, high velocity. Fabric optimized more for typical enterprise reporting volumes, with some design considerations needed at the higher end.
That's a critical distinction based on workload. Now, performance often hinges on caching. How do they approach that differently?
Databricks gives you levers to pull multiple caching layers developers can control.
Like?
Things like Delta cache on SSDs, there's a result cache, in-memory cache. You can manually configure these to tune performance.
Okay, hands-on tuning. And Fabric.
Fabric's caching is tied more closely to the consumption end. Think Power BI's import mode cache, Direct Lake, which is interesting, semantic model caches, even visual level caches. These are mostly abstracted away, auto-managed for the user.
Ah, so the pattern continues. It does. The source puts it nicely. Databricks lets you tune caching closer to the compute engine. Fabric automates caching closer to the visualization layer for BI speed.
Control versus abstraction, again. Okay, last point in this architectural bit. Batch versus streaming. Real-time data.
Big difference here. Databricks has native structured streaming built in. Autoloader, DLT. It's designed for true, low-latency, stateful, real-time processing.
Okay, true streaming.
Fabric. It has limited native streaming capabilities currently. It often simulates near real-time by using scheduled micro-batches within its data pipelines.
So scheduling frequent small batch runs.
Pretty much. So if genuinely low-latency, continuous event stream processing is a must-have.
The source points to Databricks.
Clearly, Databricks for true real-time and stateful stuff. Fabric is more geared towards batch-oriented data prep for reporting cycles.
Okay, that lays a really solid architectural foundation. Let's move up a level now and compare specific features, capabilities. Maybe start with ETL and transformation.
Sure. Databricks offers huge flexibility here, primarily through code. PySpark, SQL, Scala.
Right.
Plus the abstractions in Delta Live tables. It's really built for deep, complex, distributed data manipulation by engineers.
And Fabric. It has notebooks too, right?
It does, using PySpark. But it complements that with strong low-code, no-code options. Power Query is a big part of the story there.
The transformation engine.
Exactly.
Right.
And also using T-SQL within its SQL warehouse endpoint.
So code and low code.
Right. The implication is Databricks empowers engineers with fine-grained control for complex custom transformations. Fabric provides a spectrum-guided, low-code, even AI-assisted transformations.
AI-assisted.
Yeah, the source mentions things like Gene AI functions built in, geoanalytics, trying to democratize some of that transformation power.
Interesting. Okay, how about governance and cataloging? Super important.
Crucial. Databricks uses Unity Catalog.
You see? Yeah.
It's their central open platform, does lineage, access control, auditing, data discovery.
Like the Discover Marketplace feature.
Right. Fabric integrates tightly with Microsoft Purview.
Purview, okay. Microsoft's governance tool.
And it introduces its own common data elements, CDEs, focuses on business glossaries, lineage, classification mapped to tables, aligning with that whole Microsoft 365 governance picture.
So different focuses.
Seems so. The source notes Unity Catalog is about open, central governance and detailed pipeline lineage. Fabric, via Purview and CDE, is more geared towards business metadata and compliance within the Microsoft ecosystem.
Makes sense. And security, how do they compare there?
Both are strong, but different approaches again. Databricks offers granular control via Unity Catalog ACLs, supports things like multi-key encryption, private link for networking.
Fine-grained lake-level security.
Exactly. Fabric integrates deeply with what's now Microsoft Entra ID.
Used to be Azure AD.
Right. Standard Azure role-based access control, key vault integration, data sensitivity labels from Purview.
So Fabric leverages the standard Azure security toolkit.
Pretty much. Databricks gives you more specific controls at the lake and encryption level. Fabric aligns with familiar Azure practices.
Got it. Now, the hot topic, ML and AI capability.
Yeah, definitely hot. Databricks has a deep focus on the end-to-end ML lifecycle.
How so?
Tools like MLflow for managing the whole process.
Open source standard, right?
Yeah. A feature store, robust model serving, advanced tuning frameworks. It's built for ML practitioners doing deep work.
And Fabric's AI angle.
Fabric is really emphasizing AI-assisted workflows across the platform.
A copilot.
Exactly. Copilot integration across workloads is mentioned. Enhanced auto ML capabilities, integration points with Azure Machine Learning.
So less about building models from scratch, more about using AI to help with tasks.
That's the distinction the source draws. Databricks for the serious end-to-end ML development and governed deployment. Fabric focuses on democratizing AI, boosting productivity, making AI accessible even for business users through assistance.
Okay, different goals there. What about just traditional SQL querying and data warehousing tasks?
Both are enhancing capabilities. Databricks offers developer-focused features like Git versioning right in the SQL editor.
Right.
Tools like BladeBridge for migrating old data warehouses, and SQL extensions like Open Row Set, bulk insert for direct data access.
And Fabric.
Fabric is also enhancing its SQL Analytics endpoint with similar Open Row Set bulk insert capabilities, and it offers a migration assistant tool as well.
So Fabric is boosting its SQL usability significantly.
It is. The architectural point seems to be Fabric expanding SQL's reach within its lakehouse environment, while Databricks adds things like Git integration and specific migration tooling for developers coming from legacy systems.
Okay, data sharing. Critical for modern architectures. How do they compare?
Databricks is really a leader here with Delta sharing.
The open standard.
Exactly. Open protocol, works cross-cloud, can even share data with platforms reading Iceberg format.
Another open table format.
Right. And it's integrated into their marketplace. It's mature.
Fabric's sharing story.
At the moment, the source says it's more focused internally, using those OneLake shortcuts for sharing within Fabric and Power BI's built-in sharing features.
So external versus internal focus right now.
That's what the source highlights. Databricks has the mature open standard for external sharing. Fabric's priority seems to be internal collaboration within the Microsoft world for now.
That's a pretty clear difference.
Yeah.
Okay, great overview of features. Let's shift to the practical side. Admin, ops, dev workflows, workspaces, and administration.
Databricks workspaces are described as logical containers, good for isolating notebooks, clusters, jobs, data. Admin involves managing Unity catalog, setting granular roles, cluster management, more technical focus.
In Fabric workspaces.
They're presented as aligning more with, say, departmental BI projects or capacity planning.
Oh, okay.
Admin ties into Microsoft Entra ID for access, defining workspace roles, integrating with Purview for governance.
So more aligned with M365 admin patterns.
Exactly. The implication is Databricks workspaces offer deeper engineering isolation and control. Fabric workspaces are geared towards simpler management for BI teams, fitting into that familiar Microsoft admin model.
And ownership. Who owns what? Does that differ?
It does, in terms of granularity. In Databricks, owners manage compute, jobs, the actual data assets, permissions, often controlled via Unity catalog, very fine-grained.
Right.
In Fabric, owners typically manage datasets, pipelines, security roles, sharing. Aligns more with the Power BI concept of owning a dataset or a workspace report.
So Databricks ownership is maybe a more component-level tech team focus?
Yeah. And Fabric ownership feels more aligned with the business or BI owner of a consumable artifact.
Makes sense. What about CI/CD, DevOps practices? Crucial for development.
Databricks has strong Git integration with its repos feature, mature infrastructure as code support.
On IAC, yeah, Terraform.
Terraform, DBX CLI tool, it supports deploying notebooks, jobs, ML models through code. Pretty robust.
Fabric's approach.
Supports Git integration too, but primarily mentioned for Power BI reports and data factory artifacts at this stage.
Okay.
It uses deployment pipelines, that Power BI feature for moving things between dev, test, prod. The source notes its broader IAC support is still maturing compared to Databricks.
So Databricks is more mature for full IAC across the board.
That's the insight. More comprehensive IAC and Git integration for code, pipelines, ML, enabling better testing. Fabric is building this out, starting with BI and data integration artifacts.
What about validating data quality? How's that handled?
Databricks typically uses code. PySpark, SQL checks. Leveraging Delta constraints, defining quality expectations within Delta Live tables. You check quality early, during ingestion or transformation.
Code-based early checks.
Fabric uses validation steps within Power Query, maybe DAX calculations in the model,
Right.
or specific steps within data pipelines. checks within the semantic model itself. Validation happens closer to the consumption layer.
So different philosophies on where to validate.
Exactly. The source contrasts them. Databricks for code-heavy, rule-based validation during processing at scale. Fabric offers more GUI-based or semantic-level validation, often closer to getting reports ready.
Got it. And finally, scheduling.
Yeah.
Running these jobs and pipelines.
Databricks Job Scheduler is built for complex workflows. Think directed acyclic graphs. DAGs.
Showing dependencies between tasks.
Right. Supports complex dependencies, flexible triggers like cron schedules or event-based triggers. Built for orchestration.
And Fabric scheduling.
Uses data pipelines or Power BI service schedules, typically time-based triggers or based on dataset refreshes. More straightforward scheduling.
So Databricks for complex ETLML orchestration.
Exactly. And Fabric is more geared towards automating report refreshes and data flows for business users. More business-friendly scheduling.
Okay, that covers the operational side really well. Let's zoom out again. Ecosystem fit and vendor lock-in. Always a concern.
Yeah, a key differentiator here. Databricks was designed to be multi-cloud. Runs on Azure, AWS, GCP.
Cloud agnostic.
Though the source does note the Azure integration is particularly tight, almost feels like a first-party service there sometimes.
Interesting. And Fabric.
Fabric is all in on Microsoft, fully optimized for that ecosystem, deep integration with Power BI, M365, other Azure services. It is part of that world.
And that directly impacts lock-in, presumably.
Directly. The source rates Databricks as having lower lock-in risk. Why? Multi-cloud support and the foundation on open source like Delta Lake, MLflow.
Gives you options.
More portability. Fabric is seen as moderate risk. Understandably, given how tightly woven it is into the Microsoft stack.
Makes sense.
The architectural takeaway sums it up. Databricks allows for hybrid or multi-cloud, lets you bring your own tools, more portable. Fabric offers incredibly deep integration if you're committed to Microsoft, but less portability outside that bubble.
Okay. So we've gone through the architecture, the features, the operations, the ecosystem. Let's bring it all back to that core question from the source. Databricks or Fabric, what's the final verdict?
The source is really clear, surprisingly decisive on this. It concludes they are complementary, not competing.
Complementary. Okay, that's interesting given how they're often positioned head-to-head. Why complementary? What's the reasoning?
It boils down to using their distinct strengths at different stages of the data journey. Databricks, as we've covered, excels at the heavy lifting. Massive data volumes, complex AI and ML work, deep data transformation, sophisticated governance. It's really the domain of data engineers, ML engineering.
The data factory part.
And Fabric's complementary role.
Fabric shines at the other end of the consumption layer, democratizing access, enabling business users to get insights.
A BI focus.
Exactly, providing that integrated BI experience, especially powerful for the huge Power BI user base. It's more for data analysts, BI pros.
Okay, so Databricks for building and refining the data foundation. Fabric for making it accessible and driving insights for the business. But how do they actually connect? What's the bridge?
This is where the source highlights the crucial enabler, the secret unifier, it calls it.
Which is?
Delta Lake.
The open format. Because both use it.
Precisely. Because both Databricks and Fabric's OneLake are built on that Delta format with its A-to-D guarantees, schema evolution, time travel.
Right.
Data written by one platform can be read efficiently, natively almost, by the other. So you could do complex ETL in Databricks.
Write it out to Delta tables.
And Fabric just picks it up from OneLake, maybe via shortcuts.
Exactly. To power Power BI reports or feed other Fabric workloads seamlessly.
So Databricks preps the data at scale, writes it to this common open format, Delta Lake. And Fabric makes that readily consumable for the business, leveraging the same format. It's like Delta is the common language.
That's a perfect analogy. And the source emphasizes this benefits everyone. Business users get seamless Power BI access. Data engineers keep the power of Spark. Architects get strategic options. Stakeholders get robust platforms. Managers can optimize skills and costs. DevOps can streamline. Even existing projects can use Delta to bridge gaps.
Wow. So the verdict isn't about picking a winner at all.
Not at all. It's about intelligent architectural design.
Designing them to work together.
Yes. The source strongly advises against that either-or thinking. The winning play is to architect them together. Use Databricks for the data engineering, the AI, the complex transformations where it's strongest, and use Fabric for the consumption, the democratization, the BI layer.
And the linchpin is designing that data flow between them, using Delta Lake as that shared foundation.
Exactly. Whether it's a new project, a modernization effort, a hybrid setup, The most effective approach, according to this source, is leveraging the unique strengths of each, with Delta as the bridge.
That really reframes the whole conversation. It's not a battle. It's about building a better overall system using specialized tools that speak the same data language.
It suggests thinking in layers, absolutely, rather than trying to find one monolithic platform that does everything perfectly, which rarely exists.
Okay, so stepping back after this deep dive, the big takeaway isn't about competition, it's collaboration.
Right.
Databricks and Microsoft Fabric, they're not necessarily rivals. They could be powerful partners in a modern data stack with Delta Lake as that critical connector.
Well put. And this leaves us, and you listening, with a final thought to chew on. Looking at your own organization, your specific data challenges, the skills you have in-house, the tools you already use, where do you see the unique strengths of Databricks really adding value?
Where does the heavy lifting need to happen?
And then, where could Fabric bring the biggest benefits for getting data into hands, for driving insights, for democratization?
And maybe the most practical question, how might Delta Lake already be connecting things in your world? Or how could you use it more strategically to bridge these platforms, or maybe others, in the future?
Something definitely worth thinking about as you map out your data strategy moving forward.